Assalamualaikum and hi everyone. So in this video we will presenting our group project for STA108 assessment 2. So in this video we will talk about our topic is clothes price prediction, and we will talk about some introduction, which is the background of study, the objective of study, the significance and also the limitation of study. And the chapter 2 is the methodology, which is we will talk about the data description, the graph technique and also the numerical technique. For the chapter 3 we will explain about the result and the discussion. We will talk about the data presentation, descriptive statistic analytic, the correlation and the regression analytic. For the chapter 4 we will conclude everything.
Assalamualaikum, my name is SUPIAN. I want to discuss the topic introduction. First of all, background study. The study in question was conducted by group third semester of students enrolled in diploma in science program, specifically from class 4AS 1203-3 as the part of their course statistic and probability STA108. The student leverage the data set angle popular platform that host of data competitive for the science analytics. Their goal was analyze and plotting sell market by investigating various factors that influence the customer purchase behavior and fit with the industry. The data sheet from the get-go provide the variable secondary data that enable students explore the different that affect the both pricing and sales pattern of the fashion industry. The factor is the brand and quality. They are the significant aspect of the study was examination that influence of the brand reputation and clothing quality on the marketplace. It is well known that the higher end or luxury brand often sell their product at a premium price due to their exclusive high craftsmanship and quality. The student likely analyze how to be perceived variable of the brand affect the price on of clothing. High quality material, intricate design and superior product method typically lead to the higher prices. The evident the price of the item designer brand where the customer are willing to pay the higher price for the initially of the quality, luxury and the recognition. Additionally, the student might have the examine the customer prefer how a certain brand name can justify the higher price tags in the market. Second, seasonality. Seasonality is the crucial role in the pricing of clothing. The study likely to explore how the price fluid depending on the time of the year for spending season for specific clothing item. For example, winter wear such as the clothes, surf and clothes tend to be priced higher during the start of the winter season due to the demand. However, as the season ends, the demand increases the later or lower price and clear out the inventory. Conversely, the summer clothing such as swim, winter or light weight appear to see the price increase just before someone being picked. The study could be examining the historical data, seasonal sale, receive of the material, and manufacture ages price in anticipation of the chance of demand across different seasons, or how end of the season sale of the use. Next is market trends. Is the fashion interact dynamic and influenced by involved trends? In the analysis, the student would be have a look at how the market trend impact the clothing sale. A certain color, pattern, and type of clothing can be gained a privilege, driving up price as the demand switches. For example, when the particular celebrity influencer or social media trend books or the quality of item, the price can be so significantly higher due to increase the demand. The data sheet of the category might be all over to the type popularity of significant clothing category of the fashion over the time, helping identify their correlation in the price hiking, which can lead to discounted price when demand wanes. These are sections the study will like vulnerable estimate into how the fashion track the great opportunity for retailers to increase their price temporarily, creating environment for the fast fashion to thrive. Next is economic factor. The broader economic also can therefore impact the price. Students like they consider severe discussion can be lead to price change clothing market, for instance, during the economic fashion. The driving up of cost of clothing additionally affect the global like COVID-19 pandemic can severely describe the supply chain, particularly in collection shipping. Thus increase the final price clothing economically more affordable clothing opposite the opponents say discount. Study like that. One point, the objective. The first objective is expose the student to application of statistic knowledge about the prediction of the cloth. Second, the student aim to provide valuable instinct can be assist business in the clothing industry, making informed decision about the pricing, production and marketing strategies.
So I will explain a little bit about the significance of study. So in this study, our clothes price prediction offers substantial value to stakeholders across the fashion and retail industry. An accurate price prediction empowers retailers to refine pricing strategies. It can manage inventory more effectively and enhance demand forecasting. This improves leads to increased profitability and improves customer satisfaction. By leveraging predictive models, retailers can set optimal prices to maximize revenue while staying competitive, maintain balanced inventory levels to prevent stock outs or overstocking, and allocates resources efficiently based on anticipated demand. Consumers also benefit significantly from this research. By understanding pricing trend and pattern, they can make smarter purchasing decisions, identify the best times to buy, and compare prices across retailers, ultimately saving money. Additionally, personalized recommendation based on preference and purchase history enhance the shopping experience, fostering customer loyalty and satisfaction. Manufacturers gain valuable insight from accurate price prediction as well. Optimized production planning, supply chain management, and market analysis allow manufacturers to adjust production schedules in response to demand, reducing cost and waste. Streamlined supply chain operations help address bottlenecks and inefficiency, leading to cost saving and faster delivery time. Moreover, analyzing historical pricing data and market trends provides manufacturers with actionable insight into customer preference, enabling them to develop innovative products and target specific market segments more effectively. And plus, beyond individual benefit, this study advanced predictive analytic technique, inspiring innovation within the retail sector and contributing to the broader economy. By exploring and evaluating cutting-edge approach, the research paved the way for innovation such as dynamic pricing, personalized shopping experience, and augmented reality retail solution. These advancements have the potential to transfer consumer shopping behavior and retail operations. So, in conclusion, this study on clothes price prediction addresses the critical challenges faced by retailers, consumers, and manufacturers, empowering them with data-driven tools and to foster growth and success by driving efficiency, reducing costs, and stimulating consumer spending. The research not only benefit the fashion and retail industry but also contribute to the broader economic landscape.
Now, I will talk about the chapter 2. The data that we use for this case study, STA108, is a secondary data group. It is because we collect it from the internet. The secondary data is the data that is collected from other parties, such as journals, newspaper, internet, and etc. The data that we collect have two variables, which are the type of the material of the clothes and the price of the clothes. The data is from the qualitative nominal and quantitative continuous variable because it can be measured categorically and numerically. The independent variable as from the data that we use is the type of the material of the clothes. On the other hand, the dependent variable, why in this case study, is the price of the clothes. The population of this case study is the people that buy the clothes. So the sample size of this data is 1,000 customers that buy clothes. The link that we use to collect the data is given by the lecturer. In this case study, we use one bar chart and one histogram that we get. The bar chart related to the independent variable, which is the material of the clothes. The histogram for the dependent variable, which is the price of the clothes. Number 1. Measure of central tendency. We have a mean value formula, median value formula, and mode value formula. Number 2. Measure of dispersion. We have variance value formula, standard deviation value formula, and range value formula. Number 3. We have a measure of position. We have a maximum value formula, minimum value formula, first quartile value formula, second quartile value formula, third quartile value formula. And the 5. Regression analysis. We have a regression value of A and B value formula.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Asrie Muiz, and now we are going to proceed with chapter 3, result and discussion. 3.1 Data presentation. There are 6 types of material used, which is cotton, denim, nylon, polyester, silk and wool. As you can see at the graph, this graph shows a set of segmented histograms for the variable price separated by categories of a variable labeled material. Each panel corresponds to a specific material type, for example cotton, denim, nylon, etc. And the distribution of price for that material is visualized along with a superimposed normal curve. Key observation that we can observe is the first one, multiple materials. The data has been grouped by the material variable, and each group's price distribution is displayed in separate rows. Material include cotton, denim, nylon, polyester, silk and wool. After that, the second one is price distribution. Each histogram represents the frequency of price values within specific ranges for each material. The superimposed curve helps evaluate how closely the price distribution for each material approximates a normal distribution. Comparison across material. For cotton, it appears to have a relatively symmetric distribution centered around a mid-range price, which is approximately 100 ringgit. For denim, has a slightly broader spread with prices more evenly distributed across a range. After that, nylon, which prices appear clustered toward the lower end of the range, showing skewness. Next, polyester, similar to nylon with more prices concentrated in the lower range but with a noticeable spread. With silk, it shows a wide spread with relatively fewer prices in higher ranges. Lastly, wool, which distribution is relatively balanced with a central peak near the middle range 100. Number 4, pattern and trend. Material like nylon and polyester seem to have a lower price range compared to material like silk and wool, which exhibit wider distribution. The normal curve fits vary, with some materials showing more normal-like distribution, for example cotton and wool, while others deviate significantly, for example nylon and polyester. Next, we are going to look at histogram. This graph is a histogram with a superimposed normal distribution curve. Here are some key points and comments about the graph. The first one is variable represented. The x-axis represents the variable labeled as price. The y-axis represents the frequency of occurrence for different prices range. After that, distribution. The histogram bars show how frequently price fall within specific intervals. The overlaid curve is a normal distribution which helps visualize how closely the data follows a bell-shaped curve. The third one, key statistic. Mean average price is 106.29 ringgit. This is the center point around which the data clusters. After that, standard deviation spread 53.695. This measures the variation or dispersion of the prices. Next, sample size 1000. The data consists of 1000 observations. Lastly, box and whisker plot. This is a box plot or box and whisker plot that visualizes the distribution of price for different materials: cotton, denim, nylon, polyester, silk, and wool. Here's a breakdown. Key component of the box plot. First, boxes represent the interquantile range, which is the middle 50% of the data. The bottom of the box is the 25th percentile, and the top is the 75th percentile. Median, horizontal line in the box. The line within each box indicates the median or 50th percentile, representing the central tendency of the price for each material. The third one is whiskers, which extend to the smallest and largest values within 1.5 times the interquantile range from Q1 and Q3. Outliers, if any, would be dots outside the whiskers, and none are visible here. Next, y-axis, which represent price, indicating the range and variation for each material. For the x-axis, represent the material categories: cotton, denim, etc. Next, observation and comparison. First, central tendency. The median price is roughly similar across materials, centering around 100, though slight variation exists. Next, spread of price. Cotton, denim, nylon, polyester have a relatively small interquantile range, indicating more consistent pricing, while silk and wool show larger IQRs, suggesting greater price variability. After that, whisker length. Wool and silk have longer whiskers, indicating a wider range of prices compared to material like nylon and polyester. Wool appears to have the broadest range of prices, while nylon and polyester have more compact ranges. Number 4, symmetry. Some distribution like nylon and polyester appear more symmetric, while others like silk and wool may have slight skewness, longer whiskers on one side. For the inside, wool and silk have higher variability in prices, potentially indicating premium or luxury items with a wide pricing spectrum. Polyester and nylon are likely more standardized materials with less variation in price. The median prices are comparable, but the differences in spread and range reflect variability in product diversity and quality.
Measures of central tendency.
Mean 106.29. The mean represents the average price of the closed item in the dataset. It is influenced by all data points, including potential outlier. Median 108. The median represents the middle value when the data is arranged in ascending or descending order. It is less sensitive to outlier compared to the mean. Mode. The mode represents the most frequent price in data set. It indicates the price that occurs most often. Measure of standard deviation. Standard deviation 53.695. The standard deviation measures the average deviation of each data point from the mean. A higher standard deviation indicates greater variability in the price of closed item. Variance 288.201. The variance is the square of the standard deviation. It also quantifies the spread of the data around the mean. Range 189. The range is the difference between the highest and lowest price in dataset. It provides a simple measure of the overall spread, the data. Measure of position. For minimum, the minimum value represents the lowest price of closed item in the dataset. It indicates that the least expensive item costs 10 units of currency. Maximum 199. The maximum value represents the highest price of closed item in the dataset. It indicates that the most expensive item costs 199 units of currency. Quarter 1, 59.25, the first quartile represent the 25% of the data. It means that 25% of the closed item have price below 59.25 units of currency. Quarter 2, 108, the second quartile represent the 50 percentile of the data, which is also the median. It means that 50% of closed items have price below 108 units of currency. Quarter 3, the third quartile represent the 75 percentile of the data. It means that 75% of the closed items have price below 150 units of currency. Correlation analysis R is 0.021. This value indicates a very weak positive linear relationship between the variable. R square, coefficient of determination, is 0. This suggests that only 0% of the variance in the dependent variable is explained by the independent variable. It indicates that the model does not explain the variability of response data around its mean. Next, regression analysis. Linear regression equation. The regression equation based on the coefficient is dependent variable 108.636 plus 0.066 multiplied by 1. Coefficient slope brand 1 0.066. This indicates that for each unit increase in brand 1, the dependent variable increased by 0.06 units. The slope is very close to 0, reinforcing the weak relationship suggested by the correlation. The comment on the value. The very low R and R squared value suggests that there is almost no linear relationship between the variable.
The slope in near zero also indicates that change in brand 1 have little to no effect on the dependent variable. Overall, the model has limited predictive power in this context.
Next, for the conclusion. Based on the data that had been observed, this study identifies some of the factors affecting pricing, including material type, seasonality, market trends, and economic factors. Materials like silk and wool exhibit higher price variability, making their position with premium or luxury items. Conversely, materials such as nylon and polyester show standard pricing, with prices generally located in the lower range. Seasonality also plays an important role as prices increase during peak demand times such as winter clothing at the start of the season and fall during clearance sales. Market trend and social media influence were also to cause price rise for popular items, while wider economic factors like inflation and supply chain disruption impact production costs. Descriptive statistics reveal that the mean price is 106.29 with a median of 108 and a mode of 97. The price range reaching out from 10 ringgit to 199, with higher price usually related to premium materials. Analysis of price differences shows that cotton and wool prices are balanced around 100 ringgit, while polyester and nylon show lower pricing and less variation. Wool and silk have the widest range of prices, making their position with many market offerings. The correlation and regression analyzed show a minimal linear relationship between material type and price. The correlation coefficient, which is R, is equal to 0.021, and a near zero coefficient of determination R squared is equal to 0.000. Indicate the chosen variables explain very little variance in pricing. This shows that other factors such as brand reputation and design would play a more important role in the determining clothing prices. To sum up, our goal is to give students the information and abilities they need to understand the factors affecting clothes price prediction and sales patterns. Through the use of statistical techniques to predict fashion trends, students will know the useful knowledge about consumer behavior, market dynamics, and product demand. The ultimate objective is to strengthen students to offer accurate suggestions that help companies in the clothing industry make well-informed choices about pricing, production, and marketing tactics, improving their market share and profitability. However, the weak correlations and limited predictive power of the regression model shows the need for more complete data sets and better modeling techniques to improve price prediction accuracy.